Okay, so we're going to try a new format today. We're going to call this the two pointers approach. So someone at some point actually explained to me that most coding problems had a set of patterns, and I thought, why not try and learn those patterns? So basically, you are given a question where you have a sorted array. Usually, if in any question, if you're told the array is sorted, just to know that we are going to have to use that property anyway. So be given a sorted array of integers, and you're told to maybe find two numbers that add up to a specific target number. So let's think how such a problem might look like. Someone might say something like this, right? So you'll come in and get a number that looks sorry, let me just get this right. So someone might come in and say something like this, right? So you say these are the input numbers, and you'd have them. Okay, let me just get a fresh page. So the input numbers, and they look something maybe 2, 7, 11, 15, right? And then they tell you there's a target number. So maybe the target is something like, I don't know, what is 2 plus 9, right? So you'd have to find the two numbers that add up to a 9. Now, of course, at the onset, you don't see it all, and you want to do all of this algorithmically. So you might think to yourself, okay, the easiest way for me to do is to compare all the numbers. So to create a pair for each of them. So if you had, like, for example, 2, 7, 11, 15, and then like this, all right, so you'd create a pair for all of them. So you'd compare 2 by 2, but you don't need, like, you can't compare a number with itself. So we know this pair doesn't work, but you know this pair works, this pair works, this pair works, right? So we can just go ahead and write it out. So you have 2, 7, you have 2, 7, you have 2, 11, you have 2, 15, then you'll have again 7, and then of course maybe you can compare it like this again, 7, 2, 7, 7 doesn't work because you don't need that, but then you'd have 7, 11, and then 7, 15, and so on and so forth. So you get the idea. So by doing this, you'd be able to kind of go in and add all the numbers until you get to what you want. Now, this method by itself might not, it's actually not quite efficient. So if I also think about how I do this from a code perspective, right? So I'd say maybe the input number, maybe it's the nums. Let me see what I put there. Let me just going to go ahead and copy this item. Okay, so maybe that was the target set. So then the next thing would be, okay, how do I iterate through all of this? So I'd have to create 2 for loops, right? Something like for num in nums, right? So that I get the first list, and then for this again, right? So for the remaining bit, so that I can kind of match it out, I do another for here. So maybe for, let's say, num2, okay, so that I can compare it all in nums. So this would generate a pair for each of them, right? So if I take in num and num2, that's kind of the pair. So I do something like maybe add those two numbers. So say the pair value is equals to num plus num2, and then maybe I might want to compare is if this pair is equals to our target. I think we had set the target to 9, right? So if pair is equals to target, then maybe I'd put this in some kind of result. So maybe I'd create a pair called result up here, and maybe start out as empty, and maybe to result I'd add this value, right? So I'd add this value plus equals or whatever your language supports. You'd add this pair. Okay, so that's kind of one way to look at it. Now obviously this is just pseudocode, this will probably never run, but you get the idea. Maybe at the end then you'd return this result, and that will be the expectation. This should in theory work. However, you see there are 2 4s here, so because of that, this is definitely going to be an on to kind of approach. Another way of doing it is to think about the target numbers. Remember when we said that the values are ordered, right? So if you had the set of numbers again, so 2, 7, 11, 15, there's really no point in going through all of them, because you know at some point the numbers are going to be too large. So for example, you know that there's no point in time where this pair 15 is ever going to give you a valid output, right? So we already know that from the onset. So how can we use that? How can we use that property? Well, that's where the two-pointer approach comes in. So why not put a pointer here and a pointer here? Okay, so we start out, we see, let's do an addition of this number and this number. That's step one. When you do 2 plus 15, we get a 17. 17 is way larger than our target, so we know that that's not gonna work. So the question is, what do we do at this point in time? We check of these two numbers, which is the larger one, because remember the target is a sum and it needs to be less than that, and this is the smallest number that we can get. That means we can effectively eliminate that part. So then we'd go to the next number, 2 plus 11. Okay, so when you do 2 plus 11, we get 13. So again, this is larger than our target, so again we can eliminate that number. So then we do 2 plus 7, and now we have a 9, and that actually is equals to our target, and then we are great. Now let's assume, for the sake of argument, that this was a 2 plus 6. So if this was a 2 plus 6, you would have gotten an 8, which is less than our target, which means we would have gotten to the situation where we don't have a number that is greater than or the numbers are either greater than or less than our target. So this is also another way that the algorithm will determine it. In this case, it will determine it without a number, or without getting a result. All right, so that's well and good. I think conceptually it's kind of clear what you're trying to do there. Maybe let's now try to think how would the code actually look like. All right, so this is how you'd do it. Maybe I'd have a def and I'd have find the sum, right? So you'd need to give at least the numbers and the target. So, and then once we have that, there's some variables that I need to initialize. The first one is the pointer that's on the left, and then we have the one that's on the right. Remember the two pointers that we talked about here. So this number and this number. So you want to bring in those 2 pointers, and then you think to yourself, okay, the left one obviously starts at 0, right? The right one, where would it start? It will be at this point. Now getting there is usually just like line of the numbers. However, because this will give you the full value, right? So the total count, for us to get the index, we need to do a -1, and then that would give us the index. Now we want to make sure, remember we talked about the terminal condition here, right? So we want to make sure that at all points in time, the left is always smaller than the right, right? Then the next question is, how do I advance this algorithm, right? So I want to first of all do a sum, right? So let me just put a placeholder here. How do I advance? I don't know how I want to advance it yet, so I'll just leave it for now. But what I want to do is do a sum here. So get from the nums, like the current or the value here, so just call it that, and then I'd get the number from the nums, right? I'd get this item, and then I'd get plus what I'd look at here as, again, the nums on the left or the right one, and then see if you are at target. Now the next thing that I need to kind of check, if I found a value and this value is equal to the target, as I've said, for now I'm just going to just put this here so that I don't remember that these things needs to advance at some point. So then the next thing that I'd have to ask myself is, now that I have this information, how do I make it work, right? So I say, okay, let me first check. So if this value is equals to the target, I mean, we already found our pair, right? Exit condition, so to return, we have our pair, right? However you want to put it, maybe it's now left, now right, just return the pair. Again, this will not compile, but I think the concept is clear. Bring that out. The next thing that I might want to actually do is maybe the target is larger. Okay, so remember one in how we checked here also the target. If the target is larger, we need to move this pointer. If the target is smaller, we need to move this pointer. So let's check. So if that's kind of the next comparison. If the value we have gotten now is larger than the target, okay, so at this point in time we want to move the pointer, this one, move it back. So we do right, okay, minus minus, okay. So now this has come a bit closer. However, against this if else, okay, we want to do the left, we do a plus plus, okay. Now this definitely advances us. And now the question is, will this ever terminate? And the answer is yes. This is guaranteed to terminate. It will either terminate at this point, that is the left is now the left becomes greater than the right as we continue doing this, these additions, or this will converge and then it will be less, and then we'll know no value was found. So if we get to the end, what happens if there was no pair? So then we need to return with an empty, so we didn't find. Alternatively, at some point we'll find a pair and that will become the answer. Yeah, so this kind of pattern can be used to generally find a target number within an ordered sequence. I'll try to think of other examples that we can look at, but for now that was the concept. Thank you.